Hello, world. Um, I've got a new setup today. I'm hoping that my sound works out. I've got a friend joining us. His name is Ryan. Um, he's going to do the exercise that I walked through 2 weeks ago. He was supposed to join us 2 weeks ago. He was busy. He was busy last week. So this weekend, we're going to bang it out. And then the inspiration to do this exercise 2 weeks ago was actually because Ryan and I are embarking on a project together, and we're going to discuss a bit of that. Ryan's trying to join the Discord call, but Discord's updating. So just give me a moment. Hi, can you hear me?
Hello.
Hello! So exciting to have you on the stream.
I'm on the stream.
Yeah, we're live right now. Because
How many
it's
people we got?
7:05. What?
How many people we got?
We got zero, like always.
Awesome.
um,
Awesome.
yeah. I've texted Ike to see if they can verify that the sound's coming through okay. They did not know that we were streaming tonight, so I don't know if they're gonna
Well, my thought on the matter is that the fewer people, the better.
um
I understand you'd like a an audience, but
no. I don't care. um where is I've got a I messed up the I had a false start, and it messed up my settings for the stream on YouTube because it reset back to the default settings. Um, so I need a moment. So do you have any code to share?
yes,
That's great.
I have code that does not give the right result.
Perfect. Okay. Well, but it doesn't error. It's not erroring
What?
it. Does it error, or it just or it gives something successfully that is wrong?
The second option.
Awesome. That's fun.
How should I share it with you?
You could post it in Discord, or did you have? Would you like to share your screen? Because it'd be fun to have you edit the code.
I sent it in Discord. Would you like me to send it in a different format than copying and pasting?
I can paste it, but if we're gonna fix it, okay. So I have it now, and that's great. Do you see the link that I sent you in Discord?
Yeah.
Is there any chance? Are you comfortable going on that link and sharing your screen?
Um, if I don't have to, I'd prefer not to.
Okay. The advantage is you having hands-on editing the code to see what makes it work versus me the one doing it. That's the only difference from my end.
Okay. Yeah. Uh,
You don't have to.
I'm closing things and do not disturbing and
Ah,
you
yes,
know.
got it. That's fair enough. Stream sanitizing.
Yeah.
Okay. Yeah, I do the do not disturb is a good point, but the main thing I do for the other things is I go on another desktop.
Sorry, I'm trying to figure it out. Um, how do I select what
This is not
window
cat,
to
and
share?
it's not the dog. This is not your dad or your Uncle Paul.
Hi, Mop. I'm on stream. Love you. Bye. What were you saying, Ryan?
I don't know.
Okay.
I'm figuring it out.
I'm gonna go ahead and run your code for everybody at home. We're all at home. All right. Let's do this. We're gonna get back to that. I'm realizing you can't see my screen.
True.
Um, do you want to go to the stream? The stream's on both YouTube and Twitch, so whichever you prefer.
Uh, sure, I can go to Twitch. I don't think I'm gonna be able to get the screen sharing thing to work.
Okay.
Or I could maybe, but it's not immediately obvious how it's working. Twitch TV.
When you open that, let me make sure I sent you the right link. Yeah, it just says share screen. You can't.
No, it
Just...
was like a permissions thing. I could figure it out.
Okay. Great. Boy, you appear to have deleted a lot of the code.
I when I put your code in, it gave me some errors, so I simplified things.
So it did error. Okay, okay.
None of the code that I left out was necessary for anything that at least I was doing. Right?
Sure, sure. I probably would have commented it out and then come back to it.
Okay.
Um,
The plan was to paste this back into it.
yeah, I'm gonna do exactly that.
What is your name on Twitch?
Leave Steve. Capital L, capital S.
Okay, so it's not Willie2K.
That's true.
Wow, that's you.
So true. You see me?
Yeah, now I gotta
Do
mute
you see
this.
your code?
Yeah. So one thing about this code, I guess, that is definitely not correct is that I'm doing it on the range of 2, right?
Let's take a look.
Um,
Okay.
for I in range 2, for J in range 2, for K in
Where?
range 2.
Oh yeah, that is wrong.
Well, no.
Okay.
That's I originally had it set up more complexly, but I did this to see if it was what was wrong. It's not what was wrong.
Okay.
It's like, for example, I was
Um,
plugging in the your example matrices that had 2, like they were 2 by 2s.
yeah.
And so I was just like, okay, we'll remove that as a variable of what's going wrong.
Yeah. Now, you were claiming that this works. Well, I suppose I have to put it after transpose for it to work, but so
I was claiming
this at least prints, right? That's what you're saying.
yes.
Is this what your code looked like?
I
Might have come through incorrectly on Discord.
let me see. Let me look at what my code looks like. Yeah, there were two of those. I don't know why there would be two of those. Perhaps that was.
What should it be?
Oh wait, no, there should be two.
Yeah, two opening brackets. It looks like it copied correctly, but is PyCharm letting you do this?
Yeah.
This is an array with a single element where the number is 0.
Oh, there's a multiplication before the second length.
What about the first one?
Oh, there's two multiplications that are not here. So before both lengths, there's a yeah.
Okay.
If that makes more sense.
It makes way more sense.
Yeah.
Okay. We're given a matrix A and a matrix B. Matrix B transposed is that. Did I give you this line? Was this in the code when you found it?
No,
Cool.
I don't think.
Just because this is the way I named this variable also.
Yeah, I think I looked at
Sure.
your code for inspiration for how to format them.
Yeah, okay. Matrix C. Start with an array of zeros. Oh, well, I know part of it. Okay. We're going to come back to this.
Okay.
Yeah, okay. This is a good problem to have. This is a good, you're going to have to understand what's happening in the actual code a little bit. It's not something I'd normally talk to somebody about in their first couple weeks doing it, but this is
then
one-on-one
perhaps you
tutoring.
could brush it as.
I'll talk about it at the appropriate level.
Okay, I would. The simpler the better, though.
I swear to
'cause I
God, you
feel
can
like-
understand it. Okay.
Okay.
Just give me a second. Okay, I'm gonna see if there's any other glaring issues though. Okay, array of 0 with the same. Okay, this array, the length of this array is the number of rows in B transposed, which is the number of columns in B. So this array is width of B wide, and then it's each of these in rows. This is a good effort. This is the right way to start. Okay.
Does that give me the correct size matrix? Like.
It gives you the correct size matrix.
Right. Okay.
I
I was confident about that part.
Yeah. Let me see. It might be swapped. I forget. So this is the width of B and the height of A. I think you did that right. Yeah. Width of B, height of A. Yeah. It's the right dimensions. Okay. Now we iterate over range 2. You just did example 1, where example 1 is a 2 by 2. So you iterate over.
Yes.
The programming world has kind of like moved away from single letter iterables, um, because people realized that in programming it makes very little difference to spell stuff out. Um,
Okay.
and what it basically it's gonna help you for this loop conceptually, what is it looping over?
Um, I don't know. Matrix multiplication is harder than like thinking four moves ahead in chess in order to figure out what's happening. Like I have to do so much
Okay,
like
okay,
computation to
yeah. So uh,
keep track of.
keep
Okay, I'm going this way
keeping
on
your
this one.
variable names sensible means that you
Yeah.
don't have to think about all the moves at once. You think
Yes.
about the first move you have to make, you put it behind you, and if the variable name is specific enough that it tells you what it was being used for, then you're good.
That
Then you
seems
come back
immediately
later.
useful.
Yeah. Okay. So it looks like I represents a row number in matrix C as well as a row number in matrix A, and is not used for matrix B. I'm going to assume that there's a time symbol here.
Yes.
Oh, you know what? Discord probably italicized the things between the asterisks.
Oh, there was definitely some italicized, and I didn't really realize what was going on there.
Is there a second asterisk somewhere that I'm missing? Because it shouldn't have done it unless they were paired up.
Um,
This is really funny.
there is
Like the
not a
star.
second asterisk in that line.
Yeah. Okay. Well, weird. Um, okay. I represents a row in A. So um, I'm gonna make this be kind of like this variable name is more verbose than I would use. But we're just gonna so I could call it row A because it's the number of the row in A, but also somewhere in here, like matrix A at row A num, that's really row A, you know? Like once you pick out the specific index, now this whole thing is the one row, you know?
Right.
That's the only reason not to just call it row A. I just feel like that's insufficient. Really, the solution here for me, in Python specifically, is, and we can talk about which languages you to go which way if you want, but basically, I would iterate over the rows directly. So I would actually put row A here and have it iterate over something in a way that it is actually each row in A one at a time.
I don't understand what you mean.
Sure. Do you know what range 2 is?
What do you mean?
What do I have selected? What is this function doing?
You go like 0, then 1, like,
Yeah.
and each time you go through it,
Sure.
it's with the different variable.
So range 2 effectively just produces a list. That's all I was trying to say.
Oh, okay, got it. The 4 is the part that does what I was describing, really.
Right. So when you say for some variable in some other variable, this second thing here, you could just as easily type out You could type a
Right.
list here directly, and it would just iterate over it. And all it does is take this thing and sets it to each of these one at a time.
Right. Okay.
So that's what range 2 is doing. So you might imagine that if you put matrix A here directly, this is a list of rows. So if you put matrix A here directly, it gives you each row one at a time.
Okay, that would change the way that I do the later parts, right?
Absolutely would. Um, you would have to account for that here, right? Because here you were using the index to say which row of matrix C should be edited. Here it's quite simple though, because you were saying matrix A at an index that specifically refers to A, and what we got rid of the index, but we gave you row A instead, so you can replace that whole thing with, matrix A at a particular index just gets replaced with row A.
Right.
We're square so far?
Yeah, I'm trying to think of what row A is. Row A is the it's um
We can go up to the top and take a look if you want at the matrix, how it's represented.
okay, sure. Scroll up.
Okay, I'm just going to copy this down actually. All right, so this is matrix A.
Right.
These two pair up, which means each of these lists is a single element in this overall list.
Yes.
So because when you use the for in syntax, when you do the for loop syntax, if this thing is a list, it's going to set it to item 1 and then set it to item 2. So it sets this to this list.
Okay, so row A is one of the rows in A.
Exactly.
Got it.
And you go through this whole
Which is
code.
really a list.
Yeah, so each row is a list of cell values.
Got it.
So a matrix is a list of rows, a row is a list of values.
Right.
So you go through this whole code with A being 1, 2, the list of 1, 2, and then you go through the whole code again with row A being the list of 3, 4.
Right. So then the next row would be like for element in row A? Like for element A in row A.
Let's see how you were using J. So J is the X value in C, right? It's which, if this whole thing, so matrix C is a list of rows. If you single out a particular index, it means this thing collectively is a single row. This means J is indexing into a row in C, so J is going left to right. What number are you at in C in the particular row? It is also the same thing in B. In B, we single out a particular row, and then J is which column we're in that row.
Right.
One thing here is, let's Great.
You're about to do like a MS Paint kind of thing?
Yeah.
This is a really fun way of doing that.
All right.
What?
I said, all right. Let's get down to business. Okay. Have you seen Ace Bright before?
I think so. I might even.
It's good for pixel art and also the new version of Paint can do transparencies, but previously it was my way to do transparencies when Paint didn't have them. Also, it does animations. You can make little GIFs, and you can also export in the format that you need to export animations for them to be imported by a video game. Are you just seeing if you have Ace Bright?
Yeah, I don't.
Okay, okay, I'm gonna turn this code back to the way you had it for now. So that we can stay kind of consistent with what we're talking about, critiquing this and just figuring out what this structure. You know, I still haven't played this to see what it does. List indices must be in. Oh, I also changed this. Okay. Do you want to talk about the loops first, or do you want to talk about the problem with matrix C first?
I think Matrix C first.
I think matrix C might make the loops work, so that's a good call. Like I was talking about how I would do the loops differently, but you might have written perfectly good code down here. And here's the problem with matrix C. Let's try. Let's try making this more verbose and. So I'm just doing exactly what you did here, stretched out, and spoiler alert, it's not going to have the same result. So this outer thing you're doing is iterating over the length of matrix A and appending and adding this as a row. So for, let's use your convention in length. Yeah, we'll do that. In length of matrix A. Oh, I gotta say range. I see that you did not do this. Did you know that you could do this?
Do what?
Stick length of matrix A into the range function.
Yeah. That's how I originally had it. I just didn't feel like dealing with, okay, which matrix length do I take? I said I'd figure that out later once the code actually gave me like
Sure.
a wrong matrix.
Narrow down the complexity of the thing.
Yeah.
Okay.
Yeah, I originally had it that way and then didn't work.
Yeah. Okay. Mat C dot append a new row, right? You just kind of want one of these for each row in A. Is that right? Is that basically what you're doing here?
I think so. The other way that I saw that I could generate a matrix with all zeros was that I could append. So I think so.
Yeah. So doing this multiplication thing just takes whatever element is in here and makes there be this many of it. So
Yeah.
if you do something this many times, and the thing that you're doing is appending the things that where you started from an empty array and you're appending the same thing from before, this should return the same result. It won't.
Mm-hmm. Okay.
Let me see if this is right. 4, 4, 10, 8. You did it.
I think that's the answer.
It is. I'm looking at it right
Oh,
now.
wow. See? Okay.
Yeah.
That's great to hear.
Yeah, you multiplied matrices correctly. Based on these two different results before and after I edited it, and I'd like you to hazard. I don't think you're gonna guess, but it'd be cool to hear you try.
I don't know. One thing that I kept noticing in like every way that I tried to do it was that my first row and my second row were always the same. I don't know if that has anything to do with it.
It super duper does.
Okay. Um.
How
You're on the
about
spot here.
do you notice anything with the numbers?
Do I notice anything with the numbers?
For instance, like where the hell did 14 come from?
Yeah, 14 in this case was the sum of them. I realized that.
Okay, yeah, cool. So, um,
Other time, I guess before I figured out some other problem, I got a different issue where I think I was just getting the bottom answer, but like twice. Like I was getting 10, 8, 10, 8.
yeah, we can hazard a guess as to why that occurred also.
Well, it was probably just like a sillier thing that I just figured out.
Well, that would have been you messed up your iteration.
Yeah, and then I figured that out.
So you accidentally only did this. You only did this accidentally for the second pair of things, which yeah, but you figured that out. Okay. Okay. I'm gonna show you what's happening, and then we're gonna talk about why it's happening.
Okay.
You've got this beautiful little thing that's 0, 0, 0, 0. Okay. And you found what you wanted to have happen was say this. 4, 4, 0, 0 on the first iteration of that main loop, and then on the second iteration you wanted to go for leave this first one alone, and then 10, 8.
Yeah.
Okay.
What's up? Yeah, now's a bad time. I'm here.
Awesome. Okay. So to go from here and here to here, you did addition on these left ones. To go from here to here, you did addition on these right ones. Oops.
Yeah.
Okay. Here's what you actually did. Okay, I take it back. I am gonna actually allude to why this happened. This multiplication here, when you multiplied this array of rows, you weren't making unique copies of the row that were then separate. This row and this row were the same row. So when you do an addition here on this row, you can reference it by saying, oh, by the way, it's the first element in this outer array, but it's also the second element in this outer array. And we can talk about why that is in a second. But the point is, if you add 4 and 4 here, you're also adding 4 and 4 here because they're not different.
Right. Okay.
These are the same row, and then when you add 10 and 8, it's 14 and 12, and you add 10 and 8 here, and it's 14 and 12. I think that's right?
Yeah.
Yeah. Okay. Here's the deal. Are you good on this? I can delete this.
Yeah.
Okay.
Or you can do what my professors used to do, where they would shrink it down and put it in the corner.
I think what I'll do is do a new layer and hide the original one. A third technique.
I think there's real benefit to shrinking it down and putting it in the corner, because then it's like you can still see it if you're like screen sharing.
Okay.
You don't have to do any of them. I'm just saying, if for some reason you're teaching a lot of classes on Zoom,
Yeah.
it's an idea.
Yeah, that's good. It would be better if I were working in a vector program. What the? See, it's like, I don't know about that. No, we're bailing.
Yeah, maybe this doesn't do it the best.
Yeah. Okay, but if I were doing it in a vector program, the scaling would be fine, and you could scale infinitely, and that's not okay.
Yeah.
Here's what I'm drawing. I'm drawing computer memory because the issue we're discussing. Let's do this. The issue we're discussing has everything to do with how computer memory works. It's just a bunch of boxes. Have you heard when people talk about data types, so things like, integer versus float versus Boolean?
Yeah.
Have you heard them mention primitives?
No.
Okay. Ah, jeez. Okay. A primitive data type means that in memory, this is a simplification. Memory is complicated. This is so close to accurate, though, that it won't matter unless you actually take a really specific class. Okay. This box, the number 5 is stored in binary as a 4 plus a 1. So in other words, it takes 3 binary digits to represent that integer. But you could decide that an integer is anything that can be represented by here's 8 zeros, but you pick a number of zeros and you just say that's how big an integer is.
Right.
And in particular, the number you pick is how big a block is in memory. That evolved. I hate what I'm saying, but we're gonna pretend that that's what is actually happening. But okay, for simplification purposes, an integer goes in a box. True or false, that's just a 0 or 1. That goes in a box. Float and char. What's your favorite letter?
L.
Okay. You had to pick the one that can be ambiguous on screen. Okay.
You could have picked the letter.
I could have picked the letter. But out of 26 options, all right. Actually, O would have also been ambiguous. So 1 in 13 chance. Okay. Like people also.
You could have done a capital L.
Yeah, we're gonna do capital L. Good.
Or really, if you're gonna erase it, just change the letter. Make it.
No. You picked L.
Okay.
L is for love. L is for
Yeah.
look at me in my little box. I am a char. A char gets represented by some amount of zeros and ones, and it fits in a box. Okay. Okay, so we've got int, char, boolean, float. Let's leave that there for now. And then I don't know what, I don't know, primitive data types means something really specific in my head. Oh, compound data types, that's the other word. I was gonna write complex. Compound. This could be all sorts of crap because the moment you start combining shit, you get to like mix and match until the cows come home.
Right.
But for instance, the two that will always be in the picture are string. Let's talk about string for a second. If you have the string hello world, the letter H takes up a box. You can't put hello world all in one box because H takes up a box, and then you're only on letter 2 or letter 1, depending, whatever. You're on the E and you're like, okay, we're out of space. So for now, let's take the string hello. You would say, okay, so let's say A is 5, B is L, C is true, D is 4.3. So the computer knows that A is here in memory, B is here, C is here, D is here, right? Memory, in order to keep track of where everything is, has these things counted. Where we are in memory does not matter. We're somewhere along this long line of boxes. Let's say we're at 2006:35, 2006:36, etc. Blah blah 37. No, I'm gonna write it out. 2637, 2638, and one more, 2639. All right. Okay. E is hello. Okay. I know, is Python the only programming language you've used?
Yes.
Okay.
I I don't think I've used. I feel like I must have done like the very basics of like C or like C plus or C
Okay.
sharp or something. I don't know.
For instance, Python doesn't toss these words around a lot, but they got tossed around a lot more if you use a programming language where you have to write the type out all the time.
Right.
Um, and the other thing is Python doesn't distinguish when there's a single letter versus when there's multiple letters. Um, if you ever want a char, it just Python defaults to it being a string with a single character in it, and it makes
Right.
no difference to Python. But this is very important in a conversation about memory. Um, so the string is hello. Memory is still going to say is here, and do that, and then whatever the next thing is goes up here, right?
Right.
And there's stuff where it's going to sort out how long E is, and that's not going to change, and it might, like, let's see, 1 2 3 4 5, it might say 5 hello or something. I don't know the details on how it actually stores that.
Right. Right.
Okay, but so 2639 is E, and even though each of these have been one boxes, we get 2640, 2641, 42, 43. So F is at 2644. Okay. A string works the same as an array. I'm going to write it like this. This is in terms of naming types, if you get into other languages, this syntax means it is an array of integers. Is that fair enough?
Okay.
Or you might just say it's an int array. Okay. Let's use the example from matrix A, which is row 1 was 1 2. Okay. That's simple enough, right?
Yeah.
Okay, here's the thing. This isn't what happens. What it actually does, bloop, 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 bloop. There's a whole other part of memory dedicated to mixing stuff up on the fly. And so it's going to put the 1 2 here. And this is at spot 5236. And so here, what goes in F is just this number, 5236. This is called a pointer. And if you say F0, what you've just done is dereference F. So F is a reference, but the verb to dereference F is to look at this address and actually go there. So if you say F at 0, you're saying go to 5236, bam, add 0 to it, sticking here. What's the number in that box? And it's a 1. So there's a difference between saying give me a new array and give me a copy of the old array. Because if I say G equals F, I haven't just made a 1 2 over here with a new address that I'll give G. I've just said G is equal to 5, 2, 3, 6. And so if you say G at 1 plus equals 7, it's going to dereference G. Here's G, go to 5, 2, 3, 6, go to index 1, so it's 5, 2, 3, 7. You add 7, so this 2 is a 9. And now if you print F, it's going to dereference 5, 2, 3, 6. Look over here. It's going to print 1, 9 if you print F now.
Right.
So that's what I mean when I say they're the same.
Right. That makes sense. Why is that the case here rather than at other points? Like, can you explain why the way that I wrote this out went wrong and maybe how you would have done it differently? Like how you would have created a array of zeros.
Okay, first of all, this is a perfectly fine way to do it.
Okay, so let's break down why that's different.
Okay. This code where you've typed out this is an array of zeros. First of all, 0 is a why does it keep doing that? Okay. I can use my mouse now anyway. I think Windows Ink messes it up, and Windows Ink might not have been on that whole time, and when it turns on, I gotta figure out how to disable it, but, alright. If you have an array of zeros, a 0 is a primitive, and so if you say, we're up to H now, if I say, where was our integer? A. So A is 5. If I say H equals A, it copies what's in the box, and that's not a pointer. So H will be 5 if I say H equals A. And then if I modify H, it's modifying the 5 in the H box, not the one in the A box. Do you see the difference?
It's a primitive, so there's no pointer, so do I have to know when they're... Or how do I know when things are pointers or not?
The primitives never change. It's always these ones, no more, no less.
So...
there's also something called being immutable. So when you make a copy of a string, strings refuse to be edited. So if you make a copy of a string, it will be the pointer to the same address. But the moment you edit it, it makes a whole new memory address because strings refuse to be edited. So effectively, in that sense, in terms of strings editing each other, it doesn't happen because strings never get edited. Strings never get edited. Strings never get edited in place. It always makes a copy and edits it. So you asked, how do I know when how do I know when it's a copy and when it's not? Here, the single element inside of this array was an array. Or rather, since we're talking about memory, this outer array had a single element in it, which is, by multiplying 0 times length of we're getting a list of zeros, right?
Right.
So the single element in the outer array is a pointer to the list of zeros. And so when we multiply it, we're multiplying the list of a pointer.
Because it's an array, which is one of our...
Because which is an array?
Oh, sorry, because it's a list.
So this is like one way that I could separate this out that would not make it any better, but illustrate it better at least. Sorry. So temp is an array. Here
Right.
you're making an array that the only item is temp,
Right.
and you're multiplying it, so it's going to be, since what you're multiplying is an array of a pointer, it's gonna copy out that pointer.
Right. And arrays and strings have pointers, while the only ones that don't are chars, ints, floats, and bools.
Yeah, arguably, if it helps, we could just say, like, pointer. We could put pointer over here as our primitive data types. Oops. Like, we could just say an int can go in a box, a char can go in a box, a boolean can go in a box, a float can go in a box, a pointer can go in a box. And then everything.
I don't know that helps.
A string can't go in a box. So you need a pointer to reference the compound data type. A string is a compound data type because it's a combination of chars.
Right.
I think you should ask as many questions as you want, and we can keep hitting tiny things that don't make sense.
Yeah.
Until we start to flesh it out. I'll do whatever you tell me to do at this point.
Right. I'm just thinking and trying to I'm trying to think through whether it's just something that it's like, okay, this is how it works, and you just I think really the only way that I'm going to get a greater understanding is in the future, bumping into this problem and realizing like where the issues are. You know what I mean?
I think that that's a fair take. Let me add one tool in your tool belt in addition to the fact that you'll
Okay.
just have practice. If you watch out for it, so in terms of getting practice in this and just having enough exposure that it starts to make sense, what you should look out for is one thing that's entirely in your control is figuring out which lines of code mean that new memory has been allocated for a pointer. It's easy to identify, and I'll show you this, when a new string has been made, when a brand new string has been made, when a brand new array has been made. And if none of those things are happening, then if you haven't explicitly said one of those things, or if you haven't called someone else's code that explicitly says one of those things, and they should document their code to say whether they're doing that, then it is not happening. You should assume that somewhere a pointer is being copied unless you have specifically manually made new data.
Okay.
And I can point this out in this example.
Yeah.
Here, you definitely didn't manually recreate temp multiple times. I'll put it back the way you had it. I'm still going to call it temp though because the name's useful. Okay, this is temp. You definitely didn't specifically create it manually multiple times because this gets evaluated a single time to define this array, and it's not going to get evaluated again when you multiply it, but because the multiplication of an array is multiplying like the result of whatever was in here. This has already been evaluated by the time the multiplication happens.
Right.
This code right here is when you said make a new array. You typed out this bracket with a 0 in it. That's a new array. And you multiplied
Right.
it, and it copied the zeros because they're primitives.
Got it.
So this became an array
If I had instead done it with a for loop over like the
Narrate this for me. What's your for loop look like?
what?
Tell me. I'll type out your for loop.
It's like for I in length of matrix A for I in length of matrix A and then what do you want to do? You want to
You wanted to do this explicitly, right? So that you're explicitly doing this multiple times.
yeah, so I guess you'd put that line in and then you'd
Can you? What does that look like? Which part of it?
the temp.
Okay. I'll just do that. Right? Is this fair enough? 0. So you have temp now.
Yeah.
You're under a check. This is good.
Okay. I in range of the temp.
You have one of these. Now you just need to actually use it to make this bigger matrix. Right now,
Right.
the first iteration, you
So-
make temp, then it disappears, and on the second iteration, you make it all over again, and then it disappears.
Yeah, okay. Sorry, it's really hard for me to code on the spot.
No, good. All good. I'd rather you think. Do you want to think out loud?
No, I don't think that I benefit from not at this. Which I know is kind of boring. Sorry.
I just have no idea what's happening, and I feel like I can point you in the right direction if you.
Yeah, I'm just trying to think. What is the for I in doing?
Here. You weren't using the I, so the name is arbitrary. I just renamed it. Up here, length of matrix A was only used to make sure it happened a certain number of times. Which number row you were on was never used in the code. It was just used as a counter. So this name is arbitrary and doesn't have to be used inside the for loop because its value never matters. You know, its existence is only to make sure that this loop happens this number of times. I can actually see a way that you could use this, but I'll leave that up to you.
I don't understand your distinction. What?
Okay. There's two reasons to have an iterator in a for loop. One is if for each iteration you actually use this value. Like if you have a bunch of
Oh, wait. I get what you're saying. If you just want it to do it a certain number of times, but you're not actually using the value.
yeah, in
Which,
fact, Python has a thing where you can just put an underscore here, and that tells everybody, I don't give a shit what the value is. I just need it to happen this many times.
got it.
And then
Okay.
you don't get to use the underscore. Like, you don't get to use it as a variable value, but for the sake of understanding the loop, I'm going to put the variable in.
Right. Okay. That helps me clarify that I won't be using it.
Yeah, I will say there's a way to do it with it, there's a way to do it without it, and it just depends on which one your mind lands on. What's your end goal? What by the time this for loop finishes iterating, what should you have achieved?
Right. You're supposed to have a matrix with temp multiple times. Like you have
Yeah.
a array that is made up of temps. So
Okay, and to be clear, there's only one of them. This array only happens. You only actually make the array once. It has several items in it, but you only make one array, right?
yes.
Like, in other words, it's not an array with temp, an array with temp. It's an array with temp. Right? There's one array. You're not making the array multiple times.
Wait, so you're saying it's not the first option, it's the second option?
It's not this, it's this. And you know this. This is if we look at what matrix A is supposed to be, it's one big array. This is temp. This is temp. Temp is one row. Really, it's temp from iteration 0 and temp from iteration 1, since you've now split it out. These are no longer the same because for each iteration you have explicitly redone this code.
See, it's so, like, for example, I could do before I do the for loop, I could make a matrix C with no elements, right?
Okay.
And then then I know that you have an append written there, and I haven't looked at it because I don't really know how append works, but I think that what I'm trying to describe is append. Like, I want to do each time I want matrix C to be appended with temp. But even I don't know.
Okay, so an array has a certain length. What append does is it adds a spot at the end, and whatever you said to append, it sticks it there.
Yeah.
Is that what you want?
I think so.
What am I appending to?
To matrix C.
And what am I appending?
Temp.
Awesome.
Which
Yeah.
I feel like is just what you wrote, and
It is, but you got there.
I know. Yeah.
I wanna ask a really targeted question, which is, I'm gonna delete my code now because we have your code and it does the same thing. Do you see why this specific code, just these three characters, these are code? Do you see why in this line, and could you put it into words, why in this line these three characters only get executed once, and in this code these three characters get executed twice?
Can you say the question again?
Sure. In the same exact phrasing?
Yes.
Okay, yeah. Do you see, and can you put it into words, why these three characters in the original code only get executed once, and therefore you only have one array pointer in memory?
Wait,
But
don't the zeros get activated?
the zeros are primitives, so they get copied by this. But you've only made a single array of zeros. You never make multiple arrays of zeros in the original code. Here, this code gets called multiple times. This code also happens to get called multiple times, but earlier I told you that you can spot when this happens if you can learn to spot when a new array is being created. This is modifying an array. It has nothing to do with when new arrays are being created. This is when a new array is being created, and it only happens once up here. It happens twice down here. And I'm wondering if you can see why that's a distinction.
Okay, I'm gonna like think out loud, I think.
Yeah.
To me, it feels like Matt C should just point to the temps in each one, which is not how
Wait,
it works.
in
Which
the
makes
first one or the second one? In the original code? Or the new code?
in the new code, I still don't
You're right. You're
understand.
absolutely right. Okay, let's talk about this.
Wait, are you saying that that's right? As in,
The word for word what you said is right, but I'm not sure you understand why it's right. Is that fair?
I don't know. Maybe.
I wasn't sure if I heard a noise in the background and you had checked out.
Oh, sorry. I was getting a Q-tip.
Awesome. To clean out your ears, to listen to me better.
Yeah, except I have to take out my earbud, which is not.
Do you only have the one earbud, or like should I pause for a second?
I did only have one earbud in. Now I'm trying to put the second one in, but it's not connecting. I accidentally. Hello?
Hi. You said you accidentally and then you dropped out.
Just keep talking.
I'm just gonna keep talking. I'm gonna keep saying things like how I'm writing out the code that happens. So row. Oops. A num is 0, and we do temp is 0 times, or the array containing 0 times 2, and then we do mat c dot append.
I don't know. Whatever. My left earbud isn't connecting.
You can just take a second to clean out your ear and put the better one back in.
Okay, I just put the left ear. I just put my right earbud in my left ear.
I hate that for you, but that's okay.
I hate it for me too. I'm really not happy about the solution.
Okay.
There's only so many times that you can try to connect a earbud that is just not working.
um,
So,
so the second iteration of the loop, row A num becomes 1, and we enter into the loop, temp equals an array containing 0 stretched out by a factor of 2, and mat c dot append temp.
what does that very top line say?
It says row A underscore. I shenanigans here. Row A underscore num. I'm saying here, row A num gets set to 0.
Okay, right. You're just saying okay in the first iteration because we don't
First
actually use
iteration
rowing.
and second iteration. So this is essentially the code that's being run. Um, there's something called scope that's relevant here, but we can see why this code works without talking about scope, so we're not going to talk about scope.
Okay.
Scope just means scope just means and we're I'll let this go in one ear and out the other, but for anybody watching, scope means that the variable temp defined inside this for loop should disappear at the end of the for loop. Part of the reason why we're breezing over it is because Python doesn't do it exactly the same way that other languages do, so we might as well ignore it anyway.
Okay.
Okay. So okay. So we've got mat C is here. Okay. Matrix C points to 5236. Let's put temp here. Okay. What does this code do when this gets evaluated? But can you describe what you think happens?
On which part?
The part I just put a box around.
I don't know. It looks at the array with just one element, which is a 0.
It's not looking at an array. This only began to exist on this line, so there's no previous array to look at. It has to make it, right?
Okay.
So the moment this is evaluated, it goes to all these spots, and it finds one. Say it finds one here. And it sees that it's an array of length 1 with a 0. So 5236, 5237, 5238, 5239. So temp is 5239. Is that fair enough?
Yeah.
Then it multiplies that by 2. Realistically, when this gets multiplied by 2, it's probably going to move around in memory. There might not be double the space right in the same spot because things get crammed up next to each other. So it's probably going to move around in memory. That's neither here nor there, though. Um, long story short, um, it might as well have gotten doubled in the same place and the pointer stay the same.
Mm-hmm.
Okay. Now we do matrix C dot append temp. Here's temp, it's 5239. When we do matrix C dot append, append happens as a dereferenced thing. Really, anytime you see a dot, it's dereferencing something. That's a great.
What does dereferencing mean?
Dereferencing is, it says, dereferencing can always be, anytime you use the phrase dereferencing, you can always fill in, you can extrapolate the phrase dereferencing a pointer. So 5236, if we dereference that pointer, we get to matrix C, which is over here, and empty, 0 elements. So when you say dot, you're saying the thing to the left of the dot is a compound data type, so it has a pointer. And when you
Okay.
say dot, you, in that instant, you dereference. And as it turns out, basically matrices aren't stored just like this. They're stored just like this, but they also, tagged along in there, have this whole list of functions. They just, it writes a bunch of functions right there in memory with it that you can do to that object. And one of them is append. So when you do matrix C dot append, it goes to that memory address, it looks at the append function and does it. That's you don't need to worry about the fact that functions are stored in memory like that. What you do need to know is anytime you see this dot, in Python at least, it's dereferencing this thing. It's going.
Can you better explain what dereferencing means?
Here's a new phrase. It is going into matrix C. Like, here, matrix C is a concept, and you just have to take it on faith that if you go, I have this little map in my hands. Like my brother ran away from home, but he told me, if you ever need to find me, go to 5236. And somebody tells me, hey, I have Jack's shirt. Append Jack's shirt to Jack. I'm like, boy, I don't have Jack. I do have a pointer to Jack. I can't actually directly append anything to Jack because I do not have Jack. If I want to append something to Jack, directly modify Jack, I'm going to have to dereference the pointer. So I look at 5236, I walk down memory lane until I find house number 5236. And it's right over here. It has Jack. And I say, here's your shirt, bucko. And it puts it here. Specifically, we're not appending a shirt, we're appending temp, right? We're putting something in a box. The thing we're putting in a box is whatever is in this box. So we're not putting the whole array temp in this box. It can't fit in a box. It's always the pointer. So what goes in this box when we say matc.append temp?
Can you say it more simply? Like I don't.
Sure.
All right, I'm just not getting what.
This part happens very much at face value. The only pointer thing that's happening here is the fact that this dot append. So are we clear that this memory is all the variables that are directly referenced in your code? That like this list I've made over here as opposed to this list.
Why as opposed to the other list?
Because the way the program works is when it sees you define a variable, it puts it right in the same section of memory as all the other variables that you have specifically called out by name. And then when your code ends, it just deletes them. And if you call another
Okay.
function, it puts that function stuff right here, just to the right of it. And when that function ends, it goes back to only having your stuff. It returns to your stuff, and now it's got. That's how memory keeps track of variables across function calls, is because it just keeps stacking up the memory for each function call, and as each function returns, beep, it deletes it. Beep, 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 beep. And so if you call a function, it's going to eventually come back, and you'll still have access to the variables you needed. And if you call a different function, it reuses that same memory for this new function. It calls however many functions it wants, and eventually it returns fully to your code. And because of the way it adds off to the right and then deletes off from the right and returns back to the same spot, when it returns from the other function, you're going to have all your variables back. And so memory is made here. When you name a variable in your code, you say A equals or B equals. That's when boxes get assigned here. But if the thing on the right side isn't a primitive, it's got to find a whole other space in memory for where to put that.
Say that last part one more time.
If when I give me a new variable name.
A.
Okay. When I say A equals, whatever goes on the right here, in one shape or form, let me get rid of that circle, okay. In one way, shape, or form, whatever goes here is going in a new box labeled A. It's going in the box. If it's primitive and it fits in the box, we just stick it in the box. If it doesn't fit in a box, we put a pointer to it in the box, but we need a pointer to it. These two have names if it would help. That's called the stack. This is called the heap. This is called a stack because each function call stacks on top of each other, and every time a function returns, it removes something off of the stack. People talk about it like a stack of plates. Here's one plate.
Okay.
You put plates on top of the stack, you remove stuff from the top of the stack. You're always adding on the right and deleting from the right. So you're always looking at variables on the topmost plate.
Okay.
Okay. If something doesn't fit here, if you say A is this big, say A is like an image. An image is like a zillion pixels, and each pixel has a red value, green value, blue value. So if A is a new image, it has to go to the heap as opposed to the stack. A heap is the heap is real big, and anytime you put something on the heap, it can go anywhere in it. The stack is organized, the heap is just managing a pile.
Right, because the stack, the thing that's put in the stack is the location of where it is in the heap.
Exactly.
Okay.
So the image, if you load an image, it's going to find one continuous blob of heap, and given the fact that bits of the heap are already taken up by other things, it has no idea where it's going to find a big enough space to store your image, so it's just going to take whatever it can get. It goes wherever it's got the space.
This is starting to bring clarity to before when you said that, you have the 4 types of primitives, and then one of the primitives is a pointer. Like that. This is making me understand how a pointer is a primitive.
That's great. Yeah. So the pointers can go in these boxes. Um, Notably, the distinction between a pointer and a compound data type. Um, Very useful for understanding the stack and the heap. Again, I'm kind of simplifying some of this
Wait,
stuff. You
is
wanted that?
no,
Okay.
I need a clarification.
Yeah. Do it.
Is the primitive the thing that goes in the stack, or is the primitive the thing that the thing in the stack points to in the heap?
Say that again.
Is the primitive the thing that goes in the stack, or is the primitive the thing that the thing in the stack points to in the heap?
Okay. Um, okay. We're gonna draw out this line again.
Do you know what I mean?
I know what you mean. You're misusing the word a little bit, so I'm gonna kind of clarify
Well,
the terms.
it's a question of how do you use the word.
Yeah. So that's what we're gonna talk about. So here's the heap. Um,
Do you need a picture for it? I mean, can you answer? Like, is it
uh, uh, I. Do you want
like
to
it's
try to
not just
say?
one or the other?
Not, I think. Sorry, can you say your two things again? Because I think neither of them are a fair way to use the word. If one of them were a good use of the word, I would go with it.
Okay.
Okay.
Um, I I guess my two thoughts are either the pointer is the primitive that is stored in the stack, for example, 5236, right? Or is the pointer the um thing that is in spot 5236 in the
Got it.
heap?
Yes. This is the pointer, not this.
The the thing in the stack is.
The thing in the box. And so okay.
What box? There's
Let's
many boxes.
right. Any box. So I'm zooming in on one particular box. Here's my box, right? If I write a pointer in here, that's the pointer. When we go, and a pointer is a primitive. When we go to that spot and it's got all these things allocated to it, this is our compound data type.
Right.
So this is a pointer. You dereference a pointer to find the value that it's pointing to.
Dereference is still a word that I do not understand, but
Dereference is just when I walked down memory lane looking at the number until I found the right house.
okay.
The fact is that the computer is staring really close at the stack, at its one spot on the stack. And in order for it to look at something that's not in this area on the stack, you've got to specifically say, go find it.
Okay. I think I understand dereferencing. It seems like it's a very common thing then, right?
Yeah, super not it's a complicated word for a very, very simple concept, which is the thing is here. Dereferencing just means it's always like the first step. You dereference and then you do something. It's like you either dereference to find the object so that you can read the object. Like if it's an image and we know where the image is, but it's time to display it, we can't display it without actually looking at the image data. So we've got to dereference it to read the image data.
Right.
If we want to modify the image, dereference it so we can look at the image data and edit it in place in the heap. You said
Right. Yeah. Sorry. What does the so can you explain again? You said that dot always means something?
this dot always means dereference. I'm just saying this is if you're trying to figure out problems with pointers and you're getting confused by your own code or somebody else's code and which things are pointers and which aren't, if there's a dot, the thing to the left of the dot is getting dereferenced. The thing to the, in this case, matrix C dot append. Append, in this case, is a function that is attached to any matrix. So in this case, this append function, it's not just the append function, it is matrix C's append function. So when you call this append function that's part of matrix C, it's going to take this argument and specifically append it to matrix C. That part's not as important. The really when that's more important is say I have a cat. Okay. This part where I was talking about the dot is more relevant when your compound data types are something other than a list. So I define a new object, cat. Cat has a name. Let me do this. String. So it's got a name. Geez Louise. It's got a name and an age. Let's give it a boolean too. Bool has fleas. Okay, cat is a compound data type, and I'm using this to drive home the point that there are all sorts of things that count as a compound data type.
Right.
So just to kind of mimic the way we've been drawing this, we've got the stack. You have a cat, right?
Yes.
What's the cat's name?
Oatmeal. I don't know her age though, so
We can make it up.
we will have to make up an age.
Okay, so in our code, we write oatmeal equals, the code's going to look something like this. It kind of depends on how you set it up, but we gotta just, the simplest way is you say make a new cat and list the 3 values that go in a cat here. Name, age, has fleas. So oatmeal is 7 in William units, which are defined based on dividing oatmeal's age by 7. Then you get a William unit. I'm going to assume oatmeal does not have fleas at the moment.
Yeah.
Great. Happy for you and oatmeal. Really, we could name this variable anything, and the string name would still be oatmeal, right? In fact, let's just go ahead and do that. Just so that we don't get confused with 2 things that are the same word floating around.
Yeah.
Let's
Like
call
you
it
can call this Ryan's cat. Okay.
Sure, we could call it Ryan's cat. This is nice and small letters, though.
That's true.
Okay, so the moment you say oat equals, that is attached to our function. It gets a spot on the stack. We fair enough here?
What'd you say? Sorry, I cut out.
So in your function, whatever your function is, we're operating on this spot on the stack. The moment you type out oat equals and put a value to it, it's gonna have its own spot on the stack. It gets a box.
Right.
And if we call another function next, that if we hadn't written this and we called another function, that function's memory would start here, except we did write this, so oat gets a box, and if we call another function, that function's memory starts here.
Right.
So all I'm saying is this part means oat gets a box. Starting now, we can dismiss that entirely and just look at this part. You good?
I don't kind of get that last part.
Okay, there's kind of a division here. A division here. On the right is things that happen on the heap. On the left is related to the stack.
Oh, I get that, if that's
Yeah,
what you were saying.
That's all I was saying. This all gets evaluated, and then whatever the result is, which will be a pointer, is getting assigned to oat. How are we doing with that?
I think I'm getting it.
Okay. Let's talk about this part. The part in parentheses gets evaluated before it actually gets passed to the function. So for instance, would it help you if I wrote these things in order on the heap, or to drive the point home, can I kind of make the heap be all mixed up?
It's either is fine.
Okay, I'm gonna mix it up. Okay.
The quicker the better, though.
Yeah. Okay. 7 is a primitive. It gets a single box. Let's wait on that. Okay. As we do this, oatmeal is a string. It can't go in a single box. So before getting passed to cat, what's getting passed to cat is a pointer to oatmeal. It has to be given a spot before it ever gets passed to cat. 7 is a primitive. False is a primitive. So
so there's a pointer in the heap that points to another thing in the heap.
Okay. All of this memory, stack and heap, is kind of long-term storage. You also have the values that are actively being evaluated. We don't bother writing it down if it hasn't been stored somewhere, either in a variable or in a compound data type. So right now, before we've called the cat function, this pointer, okay, this is 5236.
Wait, sorry. How this might be beyond the scope. Why is it like a cat function? Why is it not just like
saying the name of a compound data type for any data type that you make yourself? Saying the name of it and running it as a function just is the way to make a new one.
Okay. And this is, you can't simply, because this data type has interesting qualities, you can't simply just make an array that contains those three things.
Yeah, you gain access to additional tools if you bother to do it this way.
Got it. Okay.
Yeah. Good question though. Yeah.
I assume we can explore that at some point in another
Absolutely.
exercise.
Yeah. I wasn't sure if you already knew that or not. This is a very good thing to learn at your level. Okay. Okay. So just by writing out the string oatmeal, 7 and false. 7 and false are both primitives. They can be in our immediate access memory with no problem. In other words, they haven't been stored anywhere yet. We're still working with them. We're about to pass them along to this function and see what happens. But for the moment, it doesn't actually have to do anything with them. They're both primitives. They can just be satisfied with the fact that they exist. Whereas oatmeal, when you type this out here and it gets to this spot, it's gonna give it a spot in memory, and now this whole thing in quotes is actually just 5236. So what the function cat is receiving is a pointer, an integer, and a boolean.
Where is that pointer located at?
Have you ever defined your own function?
I think so.
When you say where's the pointer located at, are you saying where is this written down, or are you saying where did that go?
Where is 5236 written down?
Um,
Is it in this
it's the same
stack
place
or is it in the
this is.
heap?
It's in neither. It's in. You've heard people. It's we until it
Is this
gets
like a
written until it gets written down somewhere. It's just it's actively being played with. Like if you write a equals 5 plus 3, it's actively playing with a 5 and actively playing with a 3. It never stores either of those in memory. It stores an 8 in memory. So
okay?
so when I'm talking about memory right now, I'm talking about storage, and there's other ways that values exist, and we're talking about different hardware components. This is like
Right.
your RAM stick, whereas your CPU is allowed to have whatever thoughts it wants. If it wants those thoughts to persist to later, it's got to write them
So
onto RAM
how
or
does
onto the hard
oat
disk.
find its way to oatmeal?
Okay, here's how. You ready? Okay.
Or better question, what is written in the box oat?
Okay. I would break this down into this line into 3 steps. Step 3 is cat returns a pointer. And stores it in oat. So this function, if I like to think of, but I've used the word evaluate a lot today, and what does that mean to you?
Honestly, in this setting, I don't really know.
Okay. I would just think about it in terms of order of operations. If I'm talking about this code being evaluated, if I say 5 plus 3 times 2 minus 6, it's going to evaluate this into an 8. Then it's going to evaluate this into a 16. Then it's going to evaluate this into 10. Evaluate just means let's break this down into pieces, and once this gets transformed into an 8, so this is the other piece of it, once this gets transformed into an 8, the original 5 and 3 may as well be gone. They have already been evaluated.
Right.
So evaluate just means break it down into what it means and turn it into the next step. It's like we got to start somewhere. Does that help?
Yeah.
It often correlates to the actual parentheses here. So thinking about it in terms of order of operations is really genuinely, like, programming has an order of operations, and it's probably it probably has a name that uses the word evaluate in it, like evaluation order or something. Um, so when I'm talking about this line, getting evaluated, how does it get evaluated? What I'm saying is, let's break down the order of operations. I see 3 steps here. One is evaluate within the parentheses. So I'm going to call these arguments. You could also call them parameters. Step 2 is whatever is in the cat function. For the simplest case, let's say this. Step 2 is put the cat on the heap. Put a new cat on the heap. So, a long time ago, during this stream, I told you that in order to distinguish when this is happening versus when this is happening, when are you accidentally copying pointers, you need to know when new pointers are being made.
Mm-hmm.
If you, we're just talking Python for now, if you see cat capitalized or any other variable type capitalized and it has parentheses, it is making a new instance of that object, and a new instance means it finds a spot on the heap and it puts itself there. So a cat.
Sorry, say that again. Just the
Sure.
same thing, just one more time.
If you see a function call that has a capital letter, that means it is making a new instance of a compound data type. That means whatever the heck this function call is surrounded by, at the instant that this is evaluated, there will be a new cat on the heap, and it will be evaluated to the pointer to that cat.
Okay.
So if this cat, if it said something like ×2, and the cat were here, it would do whatever it does to cats ×2 to a cat that's right here on the heap. But this is the pointer. It would literally be cat pointer ×2, but if there's a special rule about how to multiply cats, then, you know, whatever, that's what would happen. We don't have to lean into that, especially since you just asked me to discuss this with you another time, how to make one of these. We can drill into that another time. But let's, for now, just walk through these 3 steps.
I think, can you kind of drill into my understanding, like, how do I tell when a new pointer is being created and when, like...
Okay. First of all, one of the advantages of other languages is that it's clearer. Python makes it not clear. In Java, there's the new keyword. You never get new memory without somebody's. Oops. If somebody doesn't say new cat, it doesn't matter what they say about cats. They're always if they already had a cat and they're messing with cats and they never say new. In Java, they have never made a new cat. It's always going to be the same cat unless they call that again. C has something called malloc. In C, you directly manage your own memory. So malloc just says you've got to tell it. You say how big is a cat, get me that much memory, it gives you a pointer to that much memory that's been designated for your cat. If nobody allocates memory for a new cat, no new cat is being made. You're using the same old pointers. In Python, here are the things that can mean a new thing happened. There's also list. Tuple. Dict. Okay, here's the thing. Okay, you see how there's way more to keep track of in Python?
Yes.
Okay, here are the easy ones. Well, first of all, arrays. Anytime you just type out an array, it's new, right? It didn't exist a second ago, you typed it out. If you actually use the brackets, you typed out your own array, it's new.
Wait, when you say just type it out,
so if you say A equals and then something in brackets and B equals something in brackets, you've made two new arrays. If you say A equals something in brackets and then B equals A, you haven't typed it out. That's what I mean by typed it out. Fair enough?
Got it. Okay.
Okay.
Yeah.
These three just represent other data types that can be typed out like lists. And if you see them typed out, it's a new one.
Got it.
Okay. They correlate to these four functions. These four functions, it's not worth talking about, but some other day ask me about these. Great. These make a new list tuple. These are like capitalized functions these are called classes in Python. If I capitalize cat, I'm saying there is a cat class, and if I call it as a name, I am making a new instance of the cat class. When I hear class, you can hear template. So I make a template for all the properties a cat should have, and I attach tools to that template of things you can do with cats. And anytime you call this function, it follows that template. It fills out all the things that I said a cat should have based on what you say. And
those on the right there are essentially just pre-made versions of that.
Exactly, for these pre-made, I think you could still call them classes. We're starting to get into the weeds of how Python is set up, and I don't know much about that.
Right. Okay, fair enough.
But these are basically the reason I don't want to get into these. Mm-hmm. These do something that these could just as easily do, but which is that this function, there's more than one way to call this function, basically. Like, you could actually list out the things here, or you could put a single object here that you think should be able to be converted into a list. So there's more than one way to call these functions, but each one does result in the creation of a list or a tuple or a set or a tect. Okay. So, you asked how you know, that's how you know. If you see one of these things, it's new.
I have an idea for next time. In addition to whatever main exercise you had in mind,
Okay.
I'd love if you gave me 3 to 5 simple examples of, like, go back to the code that you had.
This thing?
No. It actually typed out. Like, it was my code and your code. Yeah, like how one of these created a new thing while the other didn't.
3 to
Can
5
you give me
examples
like
of like spotting when a new thing's been made.
yeah, just like examples and then have me say whether or not something new has been made and then you can go
Oh,
over it.
little game show. Yeah.
Yeah.
Yep.
So you can do that, give it to me. I'll
Notably
get an
here,
answer for each one.
me
Mhm.
using the list function. Okay. I'm gonna rewrite this in a way that makes it not work.
I don't like understand what that code is doing, and I don't know if it'll be the best example because like I don't fully get that code. But
I'm gonna highlight specifically the difference between typing this and typing this. Oh no, this whole thing is awful for you to understand. You're right, we're gonna skip that. Okay.
but do
Yeah.
tomorrow or in a couple days send
Yeah,
me
sometime
some
before
simple
next week.
examples. Yeah.
Next week is Thanksgiving. Oh, we're gonna be in person. Oh no. We won't be in person with each other Sunday night. But we
Is that true?
will. Well, I'll be home late Sunday night. Like, I'll probably be on the road when this stream is supposed to happen.
Got it. Okay.
So we'll be in person Monday night, I think, because I have work on Monday. We could do like a 1 day late stream though.
Yep. Or just go over it in person.
I wouldn't. Yes, we can totally go over it in person. If I can find a reason to do the stream or a way to make the stream be nice, I'd rather do that because I want people to be able to kind of follow along with what we're doing here.
Okay. Being in person is probably better for teaching. Like there are like a number of times where I felt like if only we could like be pointing and like interacting with like a piece of paper or something. Like I feel like.
Yeah. Okay, so since it's 9, can we? So first of all, other than not understanding the intricacies of how memory works, you did it. If we swap back,
Yeah.
Let's do. Length of matrix A. I think I'm just going on a whim here. This is the length of matrix B transposed. I think this is length of matrix B. It could also be the length of the first item in matrix A, but they're always supposed to be the same. So if I don't know if you figured that much out, but yeah, let's comment this out and uncomment my code down here and see if you got all the right answers. I may have just made the, yeah, where's my, oh. All right. 4, 4, 10, 8. 154, 40, 60, 50. By the way, I was really proud of the way I got this to print out. Getting all these to, no matter what the matrix is, like print it out like a matrix and have it all aligned. I thought that was really cute. 154, great. 2, negative 42, negative 102, negative 84. Great, great. Yeah, yeah. So I think the value of this exercise, there's kind of a line to be drawn in what somebody could want out of coding. You know, you can stay surface level, and there's a whole lot of things you could do surface level, and I just wouldn't call them computer science. Like, there's a whole lot of code you could do that I would not call computer science.
Right.
And I think understanding something like, not this, the distinction between this and, so like everything we talked about in the last 2 hours, right? In that we spent the whole 2 hours talking about memory, like
right.
Understanding pointers and when to use what pointer, and a big part of it is understanding your loop and knowing what is this part actually doing and what is my iterator actually, like, am I using it as a value? If I'm using it as a value, what kind of value is it? Is it just the number, or is it the row itself? You know, this kind of juggling of data, you start to get into computer science and you start to have to know your shit. So this exercise leaned pretty heavily on forcing you to toss your hat over the wall for, toss your hat over the wall into somebody else's garden in order to force yourself to jump into computer science and have to go get your hat back.
Right.
I'm okay. So we've discussed this exercise. You did do it, but for this part, which will give you a bye. You did it. I'll give you 100% on that. We're not taking off any points on.
As soon as you like plugged in your thing and then it worked, I was like, okay, I completely feel like that was like a mistake I'm okay with having made.
Yeah, super duper acceptable mistake. Yeah, not even a mistake. Like, if you don't know that that's the thing you have to worry about, you did the code. You coded the way you
Right.
knew to code, and the way you had been taught things are supposed to be able to work. Okay, so we've discussed that problem and how you did on that problem. I kind of wanted to introduce to people, at least briefly, because it is 9 p.m., the project you and I are pursuing.
Mm-hmm.
You and I have discussed this without diagrams over the phone. Here's a diagram. I'm gonna say why we're looking at this / what the project is, and very quickly breeze over what we see in this diagram, like what the diagram represents essentially, but not talk at all about how it works or what the plan is. So Ryan and I would like to do what's called an AutoEncoder. This is a type of machine learning. This is a type of AI. I suppose the definition of what counts as an AI differs from context to context. This is definitely a machine learning technique. It It is a type of neural network where a neural network is the technique that is being used in a whole lot of AIs that you've heard about. If you've heard somebody talk about deep learning, deep means look at all these columns of green dots. If you have a neural network and it's only got like 2 or 3 columns, that's shallow. If you've got like 100 columns, it's deep. And what we find is that deeper neural networks can learn more complex tasks, but they take way more data to train, and they take way longer to train. So that's that. When you hear deep learning, they're saying we took the dive in order to have a lot of data, but also a lot of layers, and therefore a lot of potential for more educated output. Okay, we're talking about doing something called an autoencoder. This is a specific type of neural network where the input of the neural network is supposed to be the same as the output of the neural network, but you impose this restriction where it's supposed to crunch the data down in the middle into a tiny bit of data and then expand it back out into the same data. We could talk about applications of neural network that does this a different time. What we're looking at here is a series of matrix transformations. These are all colored green, which I disagree with. All the ones that aren't on the very left or the very right being the same color, I think is fine. Even if the ones on the very right were all the same color, that would kind of be fine. But the ones on the left should not be the same color. So these are the input values. This is a vector that we're listing off. This is a vector in the sense of linear algebra has vectors where you list off scalar values. At this point, I'm talking directly to you, Ryan, because you haven't seen this diagram. We take this vector, we apply a matrix transformation, and we get this next layer, which is also a vector. All of these lines represent a matrix transformation. If you zero in on a single one of these inputs, zoop, 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 zoop. Geez. This input, so each of these is a number, like, usually you set it up so that these numbers are between 0 and 1. So this might be 0.7, this might be 0.2, whatever. They might be zeros and ones, depending on how you need your input to work, depending on what it's representing. This number and this line are both 2 numbers. So this is a weight. This is built into the network. Whatever number is on this line stays here, and we tweak it during training, but when the neural network is fully trained, this weight is locked in. It will not change. That this list of weights throughout this network is the brain of the thing. That is what does the calculation. So the calculation is you take the number here, you multiply it by this weight, and it goes up to this point, and at this point it gets added to all of the other inputs that were multiplied by their respective weights for this one node, and you get this result. So adding together the result of a bunch of different multiplications, you start to see how this corresponds to a matrix transformation. So this, all of the lines here are a single matrix. You take this vector, you multiply it by the matrix, the output is also a vector. And you do that again and again until you finally get this output vector, and that is the result of the whole neural network. That this output vector is the output of the program. So we're going to talk about, Ryan and I are going to bit by bit get closer to a full understanding of like theoretically why this shape, why large inputs and large outputs, but smaller network in the middle. Just a vibe of what is a neural network, what's happening here, how does this result in learning, in machine learning, and then on the whole other side of things, since Ryan doesn't have a lot of experience coding, we're taking this opportunity to break this problem down into very tiny bite-sized pieces and do a lot of code learning along the way. So I'm looking forward to that. I'm looking
Me as
forward
well.
to making these exercises and talking to Ryan about them. I'm also, Ryan, very much looking forward to hearing. I'm looking forward to observing. I love that you came up with this. I love that you came up with that other thing which targeted a big problem that people end up dealing with without knowing what they're touching.
Right.
So, thanks so much for joining me. I'm so glad that you made this work.
Of course.
Did you have anything you wanted to say to our non-existent audience before we cut out?
Thanks for joining us, guys.
Thank you.